Alright, now it's time for us to modify the header file for our microcontroller. Remember we said we'll convert it from RCC to the dereferencing pointer part to creating an instance. Now we need to do it for both the testing, okay, and we have to do it for the actual compilation to using ARM, okay, the ARM GCC and using just GCC, okay. So first of all, we will change this part in the header file, and then we'll add this part afterwards as well. Okay, let's get started with that. So we have the header file open, all right, for your specific MCU. So first of all, find hashtag define, I don't know, timer2 space, right, peripheral declaration. So this is actually what this is doing over here, is saying that, hey, you need to do this, basically dereference the timer of whatever that is, okay. But we want to change it to timer dot whatever it is, whatever is inside the timer2 register. Okay, so what we need to do is just dereference that. Okay, now we will get timer time2 dot instead. Okay, now we need to do it for all of them. So let's just go and say replace this with that. Okay, just have that there. Now you just keep doing it until you get to the end of the definition. Okay, we will stop at, let's see where we'll stop. We'll stop right there. Okay, now going back there, just go back to find hashtag define flash space. Okay, go back there. That's all you need to do for now. Okay, so this is the ARM section we just did now, right? We just did this part. Okay, now we will do the testing part for GCC. We'll create an instance for that. So what we'll do is say hashtag define hashtag if def test, then do this part, and then hashtag else do this part. So this is for ARM. This section is for ARM to use. Okay, and then obviously we just end it with end if here. Okay, so when we do the testing section for seedling, it will actually use whatever contents we write in here. And if we use ARM none EABI GCC, then it will actually use all of this. Okay. So what do we do in here? Well, what we do is we look at this section, timer def. Okay. We paste it there and call it timer2. That's it. We just created an instance for the testing section. Okay. So you replicate this for, let's say, the RTC section, then you do it for the RTC as well. Okay, but now we have timer 2, 3, 6, and 7. Okay, 2, 3. Okay, this is 3, timer 6. Okay, and then timer 7. Okay, and then we do it for the RTC as well. I'm gonna leave this up to you to complete, and I'll get back to you as soon as I'm done. So finish this part and yeah, use this as a time to just like, you have to do it for all of them, right? All of them. Okay. Okay, this is essentially what you'll have. I just defined all of it. All right, so we have everything we need to get started. Okay, that's essentially what you need to do for testing. Make a little bit of space here. You could remove that. I'm just going to keep it there. Okay, now that we have that done, let's actually pull in the Makefile and see what's going on there. let's just make sure that, okay, the Makefile, let's pull it in. Let's see what the Makefile is doing. Okay, remember we kind of modified these names, so I just quickly need to modify them as well. Okay, so it's not STM32 that anymore. This is for the linker. So this is actually L0, okay, 71 XX underscore linker, okay. And then we have to do the same for the, I think that's the section now. You know what? Let's do this. Let's create the linker file will be equal to this name here. All right. Let's actually do this. Okay. Whatever it is, and then $ linker file. Okay. That just cleans it up. So you just need to modify this each time in your Makefile, as well as the optimization, obviously, and then the CPU you are using, which is the Cortex M0 Plus. If you have M3 and so on, you just modify it here. What happens if you try to, you make this M3 and you have an M0 device? Well, the code kind of, I don't believe it will actually run. But just make sure that this is okay, right? The optimization you may change as you like. I'm using CMSIS because this is where all the files are. Okay, the linker name, because I'm using this linker here. And we are using CMSIS here because this is where the linker is. You need to specify that, -L. If you change the folder where the linker is, and maybe you call it not CMSIS and you put it in another folder like linker, then you need to say here linker, if there's like a linker folder here somewhere. Okay, or where the path is essentially with the linker script. We also changed the name of the startup file, so here we actually need to call this, let's keep it startup. All right, let's maybe just change this name over here. Okay, and to make that easier, we will just call this startup file, and we'll actually call it STM32L071XX startup, right? Startup.c. Okay, I think that's it. Let's copy that name and then actually just place it here, but not like that. Let's do this. Okay, $, yeah, that's it for the startup file. What else? I think that's it. So all you need to do is you have to specify your linker file and your startup file, okay, and then your CPU as well, and then everything else you can leave as is, and you shouldn't have any issues. Okay. So when you do make, it's gonna first of all do main.o. As you can see here, we actually specified source, right? Because this is where we're gonna put the main file. We're gonna put it in here. Okay. I haven't created that yet, so it's not gonna really work. So let me just create a main file here, main.c. In fact, my mistake. It's actually in source, so I'm not going to do that now. That's when we get to seedling, we'll do that. So I have here main.2. I don't actually need that. Let me just clean up some things that aren't needed. We have the startup, syscalls, and system. Anything else? Nope. We're just going to do a few things in main. I think this is everything. Okay. As you can see, we're using load. This is what we'll use to load the. We'll use OpenOCP to basically load the code onto the target device. When we actually do that, I'll get to how you can find out what you need to place here. Okay, and as well as the interfacing section. This will remain the same. This uploads the program, which is inside the build, which is final.elf. So we'll be using that. and we'll verify and reset the device, and basically your code will run on the device. This is just used to find out the size of the device, and this is just there for saying that, hey, we actually, these are calls and stuff. So we got startup, system, syscall. They're all inside the CMSys, as you can see, because they're all there. All right, the main will still create the section for main, and yeah, I think that's it.